Here it is, problem 4 from this year's IMO. It's a geometry problem. It's also a game theory problem. So Shan-Yu and Mulan are playing a game. We have theta as an angle between 0 and 180 known to both players. Shan-Yu makes a paper triangle tau with measurements of his choice. They then repeatedly perform the following steps. If tau has at least one angle measuring theta exactly, the game stops and Mulan wins. So Mulan, who was the hero of a Disney movie named Mulan. So if you don't know who Mulan is, doesn't really matter, but here, I guess she's the hero, right? We want Mulan to win. So if she gets an angle of theta, she wins. And Shan-Yu, who is the villain, he wants to stop Mulan obtaining that angle of theta. And what can he do? Well, he can choose the starting triangle. He can choose the angles in the triangle, and obviously he knows the value of theta, so he's going to choose a triangle that does not have that angle in it. But then Mulan can choose a point P on the perimeter of tau, different from its 3 vertices. She then makes a straight cut from P to the opposite vertex of tau, splitting it into 2 triangles. So Mulan, with her sword, is able to cut the triangle into 2, and she's able to choose anywhere on any of the 3 edges to place that point P, to cut the triangle into 2 to hopefully get an angle of theta into that triangle. But that's not it, because Shan-Yu can then choose one of the 2 triangles to discard, and the remaining triangle becomes the new tau, and only if an angle of theta is in this new triangle does Mulan win the game. So the problem is, for which real values of theta can Mulan guarantee her victory in finitely many steps, no matter how Shan-Yu plays? So feel free to read the problem again to get your head around the game and what each player can do to try to win the game. But once we understand that, what are we going to do? Well, we're going to choose a value of theta to start and just try. We know theta has to be between 0 and 180, so let's try, for example, theta is 90. If theta is 90, what can Mulan do? Well, she can place a point P to create a right angle, and by doing that, and she must be able to do that on one of those 3 sides of the triangle, she's good because both of those 2 triangles will now have a right angle. So no matter which one Shan-Yu chooses, there's a 90-degree angle in it, and Mulan wins the game. So that's good, and by the time I got to this stage, I felt like I'd gone from having no idea what the problem is asking to getting my head around the game and actually being able to find one value of theta for which Mulan wins. So with that confidence, let's try another value. So for example, 60 degrees. So again, Mulan can place P to form an angle of 60 degrees. And then what's Shan-Yu going to do? Well, he's obviously not going to choose the triangle with 60 degrees in it, because then Mulan would win. So he's going to choose the other triangle, which has an angle of 120 degrees. But Mulan is still quite happy, because what can she do now? She can place point P to cut that 120 degrees into half, into 2 angles of 60 degrees. And now, no matter which one of those new triangles Shan-Yu chooses, has a 60-degree angle in it, so Mulan wins again. All right, so we have theta equals 90 and theta equals 60 being solutions. Let's try something else. So if we have an obtuse angle like 120 degrees, what would happen? Well, in this case, because Shan-Yu can choose the starting triangle, he can just choose a triangle with 3 acute angles in it. So definitely she cannot win if theta is 120, and she cannot win if theta is greater than 90 degrees. Okay, what about theta equals 30 degrees? And actually, given what we've found so far, she actually can win if theta is 30 degrees, because we know that if theta is 60 degrees, she can obtain a triangle with 60 degrees in it. And once we have that, well, she can sort of do the same trick. Just like we cut the 120 degrees into 2 angles of 60 degrees, she can do the same thing and place point P to cut the 60 degrees into 2 30-degree angles. So again, no matter which one of those triangles Shan-Yu chooses, it's going to be a 30-degree angle in it, and Mulan is winning again. So we have theta equals 90, 60, 30, and by this stage, I'm getting a sense that Mulan can win so long as theta divides evenly into 180 degrees. Because, for example, let's just take 20 degrees, for example. So if Mulan wants to obtain an angle of 20 degrees, well, what could she do? She could cut that 60 into 20 and 40. Shan-Yu will choose the 40, and she's going to cut the 40 in half to make 20 and 20 again. And that's the idea. So long as theta is a proper divisor of 180, Mulan's going to be able to win. So here's the proof. So she can place a point P to create an angle of theta. Then the angle 180 minus theta in the second triangle is also going to be a multiple of theta, okay, because 180 is a multiple of theta, so the difference 180 minus theta would also be a multiple of theta, which means both triangles have a multiple of theta. So Shan-Yu cannot choose the triangle with theta in it, otherwise Mulan wins. He has to choose the second triangle, but then Mulan's going to do the same trick. She's going to place P to create another angle of theta, and giving here an angle of 180 minus 2 theta, which again is also a multiple of theta. Same thing for 180 minus 3 theta, 180 minus 4 theta, or 180 minus n theta for any values of n. And there's a limit on n, right? Because 180 only has so many divisors. So at some stage, we're going to reach a point where 180 minus n theta is small enough to actually be theta itself, and Mulan's going to win. Okay, almost there. So now we know that if theta is a divisor of 180, then Mulan has a winning strategy. We now need to show that if that's not the case, then she does not. So if theta does not divide 180, what Shan-Yu can do is choose a triangle to start with where none of the three angles are multiples of theta. And then it becomes impossible for Mulan to introduce a multiple of theta because she can introduce it in one triangle, but if she cuts to introduce a multiple of theta in one triangle, there cannot be a multiple of theta in the other triangle. So shown in the diagram here, if she introduces an angle of theta here, then this 180 minus theta here would not be, okay, because theta does not divide 180. We know B is not a multiple of theta from the start, from how Shan-Yu chose that triangle. So then the third angle in that triangle, again, is 180 minus those two, or using the exterior angle theorem, theta minus this angle here, ABC, is also not a multiple of theta. So if she introduces a multiple of theta here in this triangle, then all three angles in the second triangle are not multiples of theta. So Shan-Yu will then choose that triangle, and he can continue to do that, continue choosing the triangle with no multiples of theta. So therefore Mulan can never obtain any multiple of theta in the triangle, let alone the angle theta itself. And conversely, it works the other way. If she were to choose this one up here to be a multiple of theta, then this one down here would not be. So there we are, Mulan is only going to win in the case where theta is a proper divisor of 180.